Okay, general equation of a parabola. This is what we call the vertex form of a parabola. And last year, you probably saw this last year, but you were just told that this coefficient was A, probably. The value, the letter A, maybe to represent. We didn't quite go into as much detail here. But there's a relationship between that coefficient of the x or the y squared term and the location of the focus and the directrix of a parabola. So here's the deal with the parabola. I'll let you write down the formulas first. General equation is y minus k equals 1 over 4p x minus h quantity squared. That's the one that opens up or down. That's the one you're most familiar with when y is linear, x is squared. And then the other one is the one where y is squared and x is linear. It opens left or right. That's the one that's not a function. So here's the definition of a, let me give you a couple terms here, and then I'll give you the definition of a parabola. This is called the focus right here. This is called the directrix. The focus is a point. The directrix is a line that directs the parabola away from it. The vertex of the parabola would be right here. That's our vertex. And the definition of a parabola is that the distance from the directrix to a point on the parabola, of course perpendicular from the directrix, back to the focus, this distance d1 and d2, those are always equal. So as you go through that whole curve, the distance from the focus to a point on the parabola back to the directrix is always equal. In particular, here's what we care about. This distance and this distance, these are equivalent as well. Straight on through from the focus through the vertex to the directrix, those two distances are equal. So we're going to find the equation of the parabola based on some information here. The directrix is always directing the parabola away from it, so that would tell you which way it opens. A y equals -2 directrix is going to tell you that it opens upwards or downward. I think I told you that. Did I tell you the origin or the vertex is at the origin? Mm-hmm. Yeah. Okay. Just say. Otherwise, we don't know that it goes up on this one. So if I have a directrix of y equals -2, there's the line y equals -2. If the vertex is at the origin, there's v, then the focus would be located 2 units above that. And so there's a quick sketch of what my parabola looks like. And once I have a sketch of what my parabola looks like, I can go and choose one of the general equations of a parabola and plug in my vertex. So now, instead of HK being the center, HK is actually on the parabola. It's the vertex, the lowest or highest point, or the far right or far left point. So here I have y minus 0 equals 1 over 4p. I'll tell you how to find p in just a minute. X minus 0 squared, because I know it opens upward. Now, p is the distance here from either the focus to the vertex or from the vertex to the directrix. Since they are equal, it's the same thing. Okay, so p is the distance from the directrix to the vertex or from the vertex to the focus. And so in this case, what is p? 2. And so p is 2. I have y equals 1 over 8x squared, and that's it. P is 2. We're going to plug 2 in. Right there.
So, P is the distance from the direct to the vertex? Yes.
So here I have a focus at 5, 0. Let's draw our picture here. So this is the focus. I've been told that in your instructions it says the origin is the vertex. So if this is my vertex here and that's my focus there, how does this thing open? What's happening here?
Right.
It's opening right, yes. And you could tell me even more if I pushed you to do so. Where's the directrix? -5. And what is the equation of the directrix?
X equals
Yes, it would be x equals -5. So, I'm going to use the one that opens left or right equation, okay? By the way, last year, well, it doesn't come into play here, but you probably took this k and added it over here, especially if you're going to graph it on your graphing calculator. I don't know what form you used last year, but this is vertex form with the hk splitting on each side of the equal sign. But if you want to write this in function form, you just add the k over. They do that in the calculus and the calculus solutions in our AP exam. Solutions to calculus, they'll write the parabola equation in this form, but with the k added over to the other side. Yeah.
What's the arrow pointing
The p.
to? So the P equals what?
2.
Why?
Because that's the distance from here to here. Might want to even write that down. We have it in the picture up here too. So we've got x minus 0 equals 1 over 4. Okay, what's p in this case? 5, yeah. And then y minus, I'm going to run out of room here. So x minus 0 equals 1 over 4 times 5, y minus 0 squared. Or x equals 1/20th y squared is my equation. And so, in fact, a that you learned about last year, that coefficient of the x squared or the y squared term, can be found if you know the distance from the focus to the vertex or vertex to the directrix. All right, find focus and directrix and sketch y equals -1/12 x squared. So, first of all, 1/12 has to equal 1 over 4p. Do you see that right here? This has to be equivalent to 1 over 4p. It's in 1 over 4p's place, right? So p has to equal 3. Quick, yeah, you could do that mentally. Yes? Well, p is a distance, so we don't worry about its sign. But what the sign tells me here is that it's opening downward instead of upward. So if my vertex is at the origin, my directrix would have to be up here at y equals 3. That's the directrix. And my focus would have to be down here at 0, -3. So there's a quick sketch. I know what you did last year to figure out how wide it was. Neither the focus nor the directrix help us to know how wide it is. That number 1/12, as it gets more closer and closer to 0, is wider and wider and wider. Most parabolas, most of the time I draw them too narrow. But if you think about where parabolas are used in real life, like satellite dishes, they're pretty wide parabolas, right? Satellite dish is pretty wide. Older cars have behind the bowl a parabolic shape piece of metal. All right. Hey. Flight of a golf ball, flight of a rocket. We did rockets at the beginning of the year. All kinds of parabolic models here. Punting a football, Hitting a baseball over the fence.
Baseball.
James, is that a common experience for you? Hitting baseball over the fence? So, suppose a golf ball driven off the tee travels 210 yards down the fairway. During flight, it reaches a max height of 55 yards. Find an equation that describes the ball's parabolic path if the tee is at the origin and the positive x-axis is along the ground in the direction of the drive. So, should we just have the ball land in the hole?
Yeah.
Hole in one, here it is. Nothing but the cup. So it just lands there. It goes, has a height, maximum height here of 55 yards. It travels a distance of 210 yards. It actually says down the fairway here. It doesn't say it lands in the hole, but that's okay. More fun than with rocks and stuff. Or do something else, just in the air lands in the hole. Usually it lands and rolls a little bit. But let's write an equation for this thing. So which of the two forms would this be? The up-down one or left-right one? Yeah. If the let's see, what did I say here? Suppose find an equation. I don't know if I drew this right. If the t is at the origin and the positive x-axis is along the ground. Okay, this will work. So what is this coordinate right here?
105.
Yes, 105, 55. So the t was at the origin. This thing is not centered. It does not have a vertex at the origin. Okay? So I have y minus k equals 1 over 4p x minus h squared. Let's just fill in the blanks here. So y minus, what is the y coordinate of the vertex?
55.
Yes. We'll wait on p just a minute here. X minus, the x coordinate of the vertex is 105. Now, how can I find out what p is here? Well, but I don't know where the focus is here. If this is the focus, you're right. I don't know that this is the focus. And I don't know where the directrix is. Okay, what? Let me ask you this. Could I figure out p by plugging in an x and a y on the parabola? What's an x and a y on the parabola? Well, it is, but we already used that one as our h and k. We don't want to reuse that point. We'll get the trivial case. We'll just be demonstrating that the vertex is on the parabola. We already know that. So let's pick another point. 0, 0 would work. What other point would work? Yeah, which one would you like to use?
0, 0.
Me too. So 0 minus 55, wise choice. You guys are smarter than you look. So here we go. 0 0 5 squared. All right, so let's go ahead and solve this for p, please. And then we'll have our equation. So kind of the same format as what we were doing with the hyperbola. You were solving for p squared, right? Like plugging in a point. You're going to do this over and over again as you go through the equation writing process on these cards. So find p. It's like a little proportional reasoning again, right?
Yeah.
Cross multiply, divide. And then we're going to have to do something else on this. So we're going to get a positive value for p, but we've got to look at this and say, wait a minute, this parabola is opening downward, that whole term has to be negative, right? What do you get for P?
I don't think I got it right.
No, it'll be just a decimal value that.
Negative 0.00212. Oh wait, but then I have to divide by 4 too. Yes. Negative 0.00124.
Sounds familiar.
Oh, cool.
What'd you get for P?
Hold on, man.
Okay, actually, guys, you know what we could have done? I don't know why we're solving for P. We could. Because, yeah, we don't need to solve for P. What do we actually need to solve for? We want to replace this whole term. So we're actually, you could stop.
You solve for 4p.
Yeah. Well, or just how about 1 over 4p? What does 1 over 4p equal?
55.
55 divided by
105 squared.
105 squared. What do you get?
Negative 0.0049.
Yeah. I think we'll stop right there at the 8. So yes, it's kind of like the b squared versus b. Got carried away. We don't really need to know what p is. We just need to know what the coefficient of the x squared term is. So here we go. My formula then, let's find a place here to write it down, is y equals negative 0.00498 times x squared. Oh, you're right. I see what you're saying. What about? My center is not the origin. So it's y minus 55 equals negative 0.00498. And then I've got x minus, I'm going to run out of room here. What was it? 105 squared. So there's the formula that models the flight of my golf ball. So 210 yards with 55 yards high. The negative says it's pointing downwards. The fact that I have a coefficient of x squared that's fairly close to 0 is telling me that, you know, relative to how high it could be, I guess it's a pretty, yeah. We have a fairly shallow parabola, I guess. You go real high in the air. All right, so the last 3 on here, we're just going to graph these things. Here I'd go y equals 1/4 x squared. So let's see how accurate I can be. I can figure out p in this case, right?
0.
Well, the vertex is 0. We know 1 over 4 equals 1 over 4p, so p does equal 1. Just set those two equal. So which way is this one opening? Yeah, this is our standard run-of-the-mill. There's our focus. There's our directrix. I'm going to ask you for focus and directrix when you're doing these tests. And then we'll just do this. I don't know, last year you probably maybe picked a point or figured out this distance between here. Maybe you could be more accurate. But all we really care about is which way does it open, because that makes a difference in terms of our mathematical modeling. Also, it makes a difference to know if it's a function or not. Is it a sideways or is it an up-down parabola? So there's a quick sketch of an up-down parabola. All right, B, we have a shifted vertex, and this is, see this 2 has been moved over. If I were to match it up with vertex form, that's what it would look like. It's pretty common to write it in this form. You'll see this next year in calculus, because it's ready to plug into your graphing calculator and graph it. Whereas this is not what I have in green here. But if we're going to be consistent with the form I gave you, What's my vertex?
2 volt. Or is it negative 2 volt?
Other way around. 1, 2. The
Oh,
x would be 1.
yeah.
And which way is it opening? Up and down again. Now this time we have 1 over 4p equals 4. So what does p equal in this case? Good. Cross multiply, you have 1 equals 16p. P equals 1 over 16. I don't know that I can even draw that accurately on here, but 1/16 above. Here's a question for you. What's the coordinate? What's the coordinate of this focus here? Just for fun. Yeah. Oops. Goofed that up here. It's supposed to go through the vertex. Yeah, it's 1, 2 and 1/16. Yeah, good. 0.06. It's 1, 2 and 1/16 is the focus. So we said 1, 2. There's the vertex. Focus is just above it. There's the directrix just below it. All right. What's the equation of the directrix?
Y equals 1.
Yes. Fun with fractions. Just sketching it out. Well, I'm going to ask you for the focus and directrix in some cases, okay? Focus and directrix give us kind of the, as that those are closer together, it's a wider parabola. All right. Let's do the sideways one here. Everybody have that? I'll let you write that down. All right, here we go. Last one. We'll do this one in red. So, what's the vertex for this guy? 0, 2. Yes, 0, 2. And is it opening right, left, up, down? Would be down if it were y equals. So it's going to open left. 1 over 4p equals 2 over 1. 8p equals 1. P equals 1/8. It's fairly wide. So at x equals 1/8, got a focus here. See you later. Good luck. It opens to the left.